Good day, students. Today I want to solve problem under electric potential that involve moving charge from one point to another and having a work done in carrying a charge from one point to another. And the formula for work done is QVAB. Okay, and we are representing those 2 points that's being moved to as point A and point B. Okay, let's draw the diagram. There is the point. How much work is required to carry a charge of 3 times 10 raised power minus 5? Let's call it Q1 from a point 50 centimeter. So if it is 50 centimeter, point 50 centimeter from a charge. Let's say it's Q from a charge 2 times 10 raised power minus 4 coulomb. Here's a coulomb to a point. To move it from a point 50 centimeter from a charge of this to a point 20 centimeter from it. 20 centimeter from this point. I just saying that how much work is required to carry it from this point to this point from it. Is that okay? This is B. Let's call this A, point A. Is that okay? Now from here will be potential difference between this point and this point. A. Okay, point A. Now, don't forget that this point will be of higher potential than this because it's closer to the charge. Please, let's understand the question very well. How much work is required to carry a charge from a point 50 centimeter from a charge 2 times 10 minus 4 to a point this is the resident charge and is the one that we're going to be considering. But at the end, when we are getting the work done, because we are referring to this as the work in carrying, the work required to carry it, but this is resident one, that's Q1 VAB. When you carry to this point and you carry to this point, you want to know the work, the differences, the potential difference between them, which it takes place at this point. Okay, now your VAB equals Q over 4 pi E naught R. This is the formula for potential difference or electric potential. Now VAB, what does it mean? That's potential difference between A and B, between point A and B. Now let's now analyze the question. First one, potential at B due to a charge of this. Potential at B due to this charge, not this charge, due to this charge, resident charge of Q 2 times 10 raised power minus 4 coulomb, and that's VB, and it's B of higher potential because it's close to the charge, which is 1 over 4 pi E naught RB, which is, don't forget that, well, let's convert this let's call this one RB. RB equals 20 centimeter. Let's convert it to meter. divided by 100 as 0.2 meter. RA, the distance from here to here, RA equals 50 centimeter, equals to 50 centimeter, and equals 50 divided by 100, and 0.5 meter. Now, don't forget that let's separate them. And this Q, there will be Q here, VB is Q over 4 pi E naught RB. It will now be 1 over 4 pi. I want to remove this 1 over 4 pi E naught Q over, since we have okay, Q over RB, circle like this, which is now 1 over 4 pi E naught is 9 times 10 to the power 9 multiplied by, what's our charge? 2 times 10 to the power minus 4 over RB 0.2. Now VB equals, since okay, let's leave it like that. Let's go to potential at A due to a charge of Q, the same Q, 2 times 10 to the power minus 4 coulomb. Now VA will now be Q over 4 pi E naught RA cos 1 over 4 pi E naught RA over E naught, into bracket Q over RA, which is 9 times 10 to the power 9, bracket the same charge, 2 times 10 to the power minus 4 over, what is our RA? 0.5. Okay, now let's get the potential difference. Potential difference between A and B equals VAB. Now VAB equals, we are going to subtract the one that is of less potential difference from the one that is higher. This one is higher because it's close to this charge. We are not considering this charge because this is the resident charge. It's being moved from here to here. Is that okay? We are considering this one when you are getting the potential difference of the two. But when you want to get the work done, you now refer to this because the one you are carrying. Is that okay? Now you now have Q over 4 pi E naught R. Pick this one for because of higher potential. B minus Q over 4 pi E naught RA. Now VAB, let's factorize it out. This Q and 4 pi E naught is common. Q over 4 pi E naught, open bracket, 1 over RB minus 1 over RA. Okay, it will now be 1 over 4 pi E naught. I'm trying to separate it times Q, 1 over RB minus 1 over RA. Okay, now VAB equals VAB equals 1 over 4 pi naught, that's 9 times 10 to the power 9 times the charge, 2 times 10 to the power minus 4 times, okay, let's put this one in brackets, 1 over RB, which is 0.2 by 0.2 minus 1 over 0.5. VAB equals 9 times 10 to the power 9 times 2 times 10 to the power minus 4. LCM is 0.1. When you multiply it, it gives you 0.1. 0.2 0.1 will give you 0.5 minus 0.5 in 0.1 0.2. VAB equals 9 times 10 to the power 9 times 2 times 10 to the power minus 4. When you subtract, you have 0.3 divided by 0.1. Okay, VAB equals 9 times 10 to the power 9 times 2 times 10 to the power minus 4. When you divide it, you have times 3. Times 3. 9 times 2, that's 18. 18 times 3, that's 54. VAB equals 54 times 10 to the power 9, indices times plus minus 4, which is 54 times 10 to the power 5 volts, can still be written as VAB equals 54,000,000,1,2,3,4,5,6. That is 5,400,000 volts. Now let's now come to the work done in carrying this charge. Work done equals Q1 VAB. Carrying this charge, you want to know the potential, the work done in carrying this charge from this point to this point, also to this point. Difference will now be Q1. We now use 3 times 10 to the power minus 5 times, what's VAB? Let's use 54 times 10 to the power 5. Okay, when you do that, the work done will be 3 times 54 times 3, that's 2, 15, 16, that's 162 times 10 to the power minus 5 plus 5, which is 162 times 10 to the power minus 5 plus 5 is 0, and 10 to the power is 0 is 1. Now work done equals 162 times 1, which is 162 joules. This is the work done in carrying the charge of 3 times 10 to the power minus 5. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.